Hello there, and welcome to Nightly Knowledge. I'm so grateful you found your way here tonight. Perhaps the day has been overwhelming, filled with deadlines and noise, or maybe you simply find peace in contemplating the infinite darkness that surrounds our small blue world. Either way, you've arrived at exactly the right moment. There's nothing urgent waiting for you now. No emails to answer, no problems to solve, no schedules to keep. Just you, this moment, and the gentle pull of cosmic wonder drawing you towards sleep. Tonight we drift into the infinite embrace of the universe, where stars are born in silence and galaxies dance through time at speeds beyond imagination. Above you right now, countless worlds spin in darkness, each one carrying stories written in light that began its journey before humans ever looked up at the sky. The cosmos is patient. It has waited billions of years to share its secrets with minds capable of wonder. Every photon that touches your eye tonight traveled unimaginable distances just to reach you in this moment. The universe is not empty space dotted with light. It is a living tapestry where matter and energy weave together in patterns so beautiful they could bring you to tears. Tonight we will explore 100 gentle truths about the cosmos, each one a soft whisper from the depths of space and time. These are not facts to memorize, but invitations to marvel. Stories that remind us how small we are, yet how connected to everything that has ever existed. If you enjoy these peaceful journeys through the cosmos, I invite you to like and subscribe or share a thought below. It helps other stargazers find their way here too, one sleepy soul at a time. But for now, just breathe. Let your eyes grow heavy as we begin our gentle voyage into the infinite night. Let the vastness cradle your thoughts and the silence of space quiet your mind. The universe has been waiting for you. Let's begin. The nearest star to our solar system would take over 4 years to reach, even if you could travel at the speed of light. Proxima Centauri sits quietly in the constellation Centaurus, glowing with a dim red light that has been shining for billions of years. The distance to this cosmic neighbor is so vast that if you could shrink the space between Earth and our Sun to the width of a single piece of paper, Proxima Centauri would still be over 2 miles away. Light from this star left its surface over 4 years ago, carrying with it the story of a world so distant that every message we might send would take nearly a decade to receive a reply. Your body contains atoms that were forged inside the cores of dying stars. The calcium in your bones, the iron in your blood, the oxygen you breathe right now, all of these elements were born in the nuclear furnaces of ancient suns that lived and died long before our solar system existed. When those massive stars reached the end of their lives, they exploded in spectacular supernovas, scattering these precious atoms across the galaxy like cosmic seeds. Over billions of years, gravity gathered this stellar dust into new worlds, new atmospheres, and eventually new life. You are not separate from the cosmos. You are the cosmos becoming aware of itself. There are more possible games of chess than there are atoms in the observable universe. The number of potential chess games exceeds 10 to the power of 120, while the estimated number of atoms in the entire observable universe is around 10 to the power of 80. This mathematical poetry reveals something profound about complexity emerging from simplicity. Just as the universe builds infinite variety from a handful of fundamental particles, The game of chess creates boundless possibility from just 32 pieces on 64 squares. Both remind us that even the simplest rules can give birth to beauty beyond measure. A single teaspoon of neutron star material would weigh about 6 billion tons on Earth. When massive stars collapse, their cores compress so violently that protons and electrons are crushed together to form neutrons. The result is matter so dense that a sugar cube-sized piece would have the same mass as all of humanity combined. These stellar remnants spin with incredible precision, some rotating hundreds of times per second while maintaining accuracy that rivals the most precise atomic clocks. They are cosmic lighthouses, sweeping beams of radiation across space with such regularity that astronomers use them to study the fabric of space and time itself. The Milky Way galaxy is on a collision course with the Andromeda galaxy, but the event will be surprisingly gentle. In approximately 4.5 billion years, these two spiral galaxies will begin their cosmic dance, gravitationally embracing each other in slow motion. Despite containing hundreds of billions of stars each, the vast distances between individual stars mean that actual collisions will be extraordinarily rare. Instead, the galaxies will merge and reshape each other, creating new spiral arms and perhaps triggering bursts of star formation. By the time this happens, our sun will have already evolved into a red giant, so any life on Earth will have long since found new homes among the stars. There are planets made entirely of diamond floating through space. Some carbon-rich worlds orbit pulsars under such extreme pressure and temperature that their surfaces have crystallized into pure diamond. These glittering worlds reflect no sunlight because they orbit the remnants of dead stars, existing as invisible jewels in the cosmic dark. The pressure required to create such planets exceeds anything we can replicate on Earth, forged in the aftermath of stellar explosions that compressed carbon into the hardest material known. They drift silently through space, their faceted surfaces catching only the faint radiation of their pulsar companions. The cosmic microwave background radiation is the afterglow of the Big Bang, and it fills every corner of the universe. This faint whisper of ancient light carries the thermal echo of creation itself, cooled by billions of years of cosmic expansion to just 3 degrees above absolute zero. When you tune a television to a channel with no signal, about 1% of the static you see comes from this primordial radiation. It is the oldest light in the universe, released when the cosmos first became transparent, about 380,000 years after the Big Bang. In its subtle patterns, astronomers can read the story of how matter first began to clump together, eventually forming the galaxies and stars we see today. Saturn's moon, Enceladus, shoots geysers of water ice into space from its south pole. Beneath its frozen surface lays a global ocean that may contain twice as much water as all of Earth's oceans combined. The gravitational pull of Saturn flexes and heats the moon's interior, keeping this hidden sea liquid despite the frigid cold of the outer solar system. The ice geysers create one of Saturn's rings, fed continuously by this distant moon's subsurface ocean. Scientists believe this hidden sea might harbor the chemical ingredients necessary for life, making Enceladus one of the most promising places to search for biology beyond Earth. Jupiter acts as a cosmic vacuum cleaner, protecting the inner solar system from dangerous asteroids and comets. Its immense gravity deflects or captures many objects that might otherwise threaten Earth. Over billions of years, Jupiter has swept up countless pieces of debris, its influence extending far beyond its own orbit. The planet's Great Red Spot, a storm larger than Earth that has raged for centuries, demonstrates the incredible energy contained within gas giant worlds. Without Jupiter's gravitational guardianship, life on Earth might have faced far more frequent and devastating impacts from space rocks throughout history. The surface of Venus is hot enough to melt lead, with temperatures reaching nearly 900 degrees Fahrenheit. Its thick atmosphere creates a runaway greenhouse effect so intense that it traps heat more efficiently than Mercury, despite being twice as far from the Sun. The atmospheric pressure on Venus is 90 times greater than Earth's, equivalent to being nearly half a mile underwater in our oceans. Sulfuric acid clouds shroud the planet in perpetual yellow haze, while lightning crackles through the toxic atmosphere. Yet billions of years ago, Venus may have had liquid water oceans and could have been a world where life might have emerged. There are more galaxies in the observable universe than there are stars in the Milky Way. Astronomers estimate over 2 trillion galaxies exist within the portion of the universe we can see, each containing billions or hundreds of billions of stars. This means the total number of stars in the observable universe exceeds 10 to the 24th power, a number so large it challenges comprehension. Every galaxy represents an island universe, a collection of stars, planets, and possibilities separated by millions of light years of mostly empty space. The light from the most distant galaxies we can observe left them when the universe was young, showing us cosmic history frozen in time. Pluto takes 248 Earth years to complete one orbit around the Sun. Since its discovery in 1930, Pluto has not yet completed a full trip around our star and will not do so until the year 2178. From Pluto's surface, the Sun appears as just a bright star, providing only 1,000th of the light that reaches Earth. Temperatures on this distant world plunge to nearly 400 degrees below 0 Fahrenheit, cold enough to freeze nitrogen into snow. Despite being reclassified as a dwarf planet, Pluto remains a fascinating world with 5 known moons and a complex relationship with its largest companion, Charon. Black holes do not actually suck things in like cosmic vacuum cleaners. They warp space and time so severely that anything crossing their event horizon cannot escape, but objects can orbit them safely just like planets orbit stars. The event horizon is not a physical surface, but rather the point of no return, where the curvature of space-time becomes so extreme that all paths lead inward. Time itself slows down near a black hole due to its intense gravity, meaning that someone falling in would appear to freeze at the edge from an outside observer's perspective. These cosmic monsters can contain the mass of millions or billions of suns compressed into regions smaller than our solar system. The International Space Station orbits Earth every 90 minutes, traveling at over 17,000 miles per hour. Astronauts aboard this floating laboratory experience 16 sunrises and sunsets each day as they circle our planet. Despite being only about 250 miles above Earth's surface, the station exists in a state of continuous free fall, creating the weightless environment that allows astronauts to float. The station serves as humanity's permanent foothold in space, a place where people from different nations work together to push the boundaries of science and exploration. Mars has the largest volcano in the solar system, Olympus Mons, which towers nearly 14 miles high. This massive shield volcano is roughly the size of Arizona and rises 3 times higher than Mount Everest. The mountain's gentle slopes result from millions of years of lava flows building up layer by layer in the low gravity of Mars. From its base to its peak, Olympus Mons spans over 370 miles, making it not only the tallest mountain on Mars, but also one of the largest volcanoes in the entire solar system. The thin Martian atmosphere means that climbing to its summit would take you above most of the planet's atmosphere. The Sun converts 4 million tons of matter into pure energy every second through nuclear fusion in its core. This incredible process has been continuing for nearly 5 billion years, transforming hydrogen into helium while releasing the light and heat that makes life on Earth possible. The energy created in the Sun's core takes thousands of years to work its way to the surface, meaning the sunlight warming your face today began its journey when human civilization was just beginning. The Sun contains 99.8% of all the mass in our solar system, holding everything in its gravitational embrace with gentle, invisible hands. Light pollution has hidden the Milky Way from 80% of the world's population. In our modern cities, the glow of artificial lights washes out the faint starlight that once guided our ancestors across oceans and deserts. Only in the darkest places on Earth can you still see the ghostly arc of our galaxy stretching from horizon to horizon, a river of light made from the combined glow of hundreds of billions of distant suns. This celestial tapestry that inspired countless myths and stories throughout human history is now invisible to most children growing up today. Yet above every city, beyond the dome of orange glow, the stars continue their ancient dance, waiting patiently for the lights to dim so they can once again tell their stories to those who look up in wonder. The Great Red Spot on Jupiter is a storm that has been raging for over 300 years. This massive hurricane is larger than 2 Earths placed side by side, with winds reaching speeds of over 400 miles per hour. The storm's distinctive red color comes from complex chemical reactions in Jupiter's atmosphere, creating a swirling masterpiece that has fascinated astronomers since its discovery. Unlike storms on Earth that dissipate quickly, Jupiter's Great Red Spot persists because there are no continents or solid surfaces to slow it down. The storm slowly drifts around the planet, changing size and intensity over decades while maintaining its hypnotic, eternal rotation in the gas giant's turbulent atmosphere. Voyager 1, launched in 1977, is now over 14 billion miles from Earth and still sending data back home. This robotic explorer has traveled farther from Earth than any human-made object, crossing into interstellar space, where the sun's influence finally gives way to the vast emptiness between stars. The spacecraft carries a golden record containing sounds and images from Earth, including music, greetings in dozens of languages, and the cry of a newborn baby. Its radio signals, traveling at the speed of light, now take over 22 hours to reach Earth. Voyager continues its lonely journey through the cosmic dark, a small piece of human curiosity drifting towards stars that won't be reached for tens of thousands of years. The moon is gradually moving away from Earth at a rate of about 1.5 inches per year. Billions of years ago, the moon appeared much larger in our sky and was close enough to create tides that were hundreds of feet high. This slow recession is caused by tidal forces that transfer energy from Earth's rotation to the moon's orbit, gradually pushing our celestial companion farther away while slowing Earth's rotation. In the distant future, Earth days will become longer, and total solar eclipses will no longer be possible as the moon becomes too small to completely cover the sun. This cosmic dance between Earth and moon has been choreographed by gravity for over 4 billion years, a slow waltz that shapes the rhythm of our planet's days and nights. Neutron stars can have magnetic fields trillions of times stronger than Earth's. These collapsed stellar cores generate magnetic forces so intense they could erase every credit card on Earth from thousands of miles away. The magnetic field lines around a neutron star become twisted and stretched as the star rotates, occasionally snapping and reconnecting in violent bursts that release more energy in seconds than our sun produces in years. Some neutron stars, called magnetars, possess magnetic fields so powerful they distort the very atoms in their vicinity, creating exotic forms of matter that cannot exist anywhere else in the universe. These cosmic lighthouses sweep beams of radiation across space with clockwork precision, their magnetic fields sculpting the surrounding space into invisible cathedrals of force. The asteroid belt between Mars and Jupiter contains less total mass than Earth's moon. Despite its fearsome reputation in science fiction, the asteroid belt is mostly empty space, with rocky debris scattered so widely that spacecraft routinely pass through it without encountering a single stone. If you were standing on one asteroid, the next nearest one would likely appear as just a faint point of light, if visible at all. The largest asteroid, Ceres, is now classified as a dwarf planet and contains about 1/3 of the belt's total mass. These cosmic remnants represent the leftover building blocks from the formation of our solar system, fragments that never quite managed to assemble themselves into a full-sized planet due to Jupiter's gravitational interference. Alpha Centauri, our nearest stellar neighbor, is actually a system of 3 stars locked in an eternal gravitational dance. 2 sun-like stars orbit each other every 80 years, while a smaller red dwarf star circles the pair at a much greater distance. This triple star system offers a glimpse into the complexity of stellar relationships, where gravity weaves intricate patterns across space and time. From the surface of any planets that might exist there, the sky would be illuminated by multiple suns, creating a celestial light show impossible to imagine from our single star perspective. The gravitational interplay between these 3 stars has continued for billions of years, a cosmic ballet performed in the depths of space. Saturn's rings are incredibly thin, spanning nearly 200,000 miles across, but measuring only about 30 feet thick in most places. If you could shrink Saturn's rings down to the size of a compact disk, they would be 10,000 times thinner than a human hair. These delicate structures are composed of countless ice particles, from tiny grains to house-sized chunks, all orbiting Saturn in perfect formation. The rings are not solid, but rather billions of individual moonlets following their own orbital paths, creating gaps and waves that ripple through the system like water. Shepherd moons help maintain the ring's structure, their gravity herding ice particles into narrow bands while gravitational resonances carve intricate divisions through the icy debris. The cosmic web connects all galaxies in the universe through vast filaments of dark matter, like a three-dimensional spider web spanning billions of light years. These invisible threads guide the flow of ordinary matter through space. Galaxies form along these filaments like pearls on cosmic strings, while enormous voids contain almost nothing at all. The largest structures in the universe are these web-like patterns created by dark matter's gravitational influence during the first billion years after the Big Bang. Computer simulations reveal this hidden architecture, showing how matter flows along these pathways like blood through cosmic arteries, feeding the formation of galaxy clusters and leaving vast empty regions between the strands. Europa, one of Jupiter's moons, likely contains more water than all of Earth's oceans combined beneath its icy surface. This frozen world experiences constant tidal flexing from Jupiter's gravity, which generates enough heat to maintain a liquid ocean beneath miles of ice. The moon's surface is crisscrossed with fractures and ridges where the ice cracks and reforms, creating patterns that suggest the hidden ocean below sometimes breaks through to the surface. Scientists believe this subsurface sea could be over 60 miles deep, making it one of the most voluminous bodies of liquid water in the solar system. The possibility that life might exist in this dark ocean has made Europa one of the most intriguing targets for future space exploration. A day on Mercury is longer than its year. This small planet takes 88 Earth days to orbit the Sun, but rotates so slowly that one Mercury day lasts 176 Earth days. This strange relationship between Mercury's rotation and orbit means that if you could stand on its surface, you would see the sun rise, stop, move backward, stop again, and then continue across the sky before setting. The planet's eccentric orbit and slow rotation create temperature extremes ranging from over 800 degrees Fahrenheit on the sunny side to minus 300 degrees in permanent shadow. Despite being the closest planet to the Sun, Mercury has water ice hidden in craters at its poles where sunlight never reaches. The observable universe has a boundary, but it's not an edge in space, but rather a limit in time. We can only see as far as light has had time to travel since the Big Bang, creating a cosmic horizon roughly 46 billion light years away. This boundary moves outward as time passes, revealing new regions of the universe that were previously hidden beyond our cosmic horizon. What lies beyond this observable edge remains a mystery, but the universe almost certainly extends far beyond what we can see. The boundary exists not because space ends there, but because the light from more distant regions hasn't had enough time to reach us yet, creating a natural limit to our cosmic perspective. Ganymede, Jupiter's largest moon, is bigger than the planet Mercury and has its own magnetic field. This icy world generates aurora displays at its poles, created by charged particles interacting with its magnetic field in ways similar to Earth's northern lights. Ganymede's magnetic field is thought to be generated by a liquid iron core, making it unique among moons in our solar system. The moon's surface tells a story of ancient impacts and geological activity, with both dark, cratered regions and bright, grooved terrain that suggests internal forces once reshaped its icy crust. Hidden beneath this frozen landscape, scientists believe Ganymede harbors a subsurface ocean that may contain more water than all of Earth's oceans combined. The center of our galaxy harbors a supermassive black hole with a mass 4 million times greater than our Sun. This gravitational monster, known as Sagittarius A star, sits quietly at the Milky Way's heart, surrounded by a dense cluster of stars that orbit it at incredible speeds. Some of these stars complete their orbits in just 16 years, reaching speeds of over 7,000 kilometers per second as they swing around the black hole. The black hole itself remains invisible, detectable only through its gravitational effects on nearby stars and the occasional flare of radiation when it consumes nearby matter. This cosmic anchor holds our entire galaxy together, its immense gravity helping to maintain the spiral structure that makes the Milky Way one of the most beautiful galaxies in the local universe. Space is not completely empty, but filled with an incredibly thin soup of particles and radiation. Even in the most perfect vacuum that humans can create, space contains about 1 particle per cubic centimeter. The space between galaxies contains even less matter, with densities so low that you might encounter only a few hydrogen atoms in a volume the size of a basketball. Yet even this near-perfect emptiness buzzes with quantum activity, where virtual particles constantly pop into existence and annihilate each other in fractions of a second. The cosmic microwave background radiation permeates all of space, creating a faint glow that represents the cooled remnant of the Big Bang's intense heat. Betelgeuse, the red supergiant star in the constellation Orion, could explode as a supernova at any time within the next 100,000 years. When this massive star reaches the end of its life, it will briefly outshine the entire rest of the Milky Way galaxy, becoming visible during the day and casting shadows at night. The explosion will be spectacular but harmless to Earth, located safely over 600 light-years away from this stellar giant. Betelgeuse has already begun showing signs of instability, dimming and brightening unpredictably as its outer layers pulsate and shed material into space. If it exploded tonight, we wouldn't see the light for over 6 centuries, yet the explosion might have already happened, and its brilliant light could be racing toward us through the cosmic dark. Time moves slower in stronger gravitational fields, a phenomenon that affects even satellites orbiting Earth. Global positioning satellites must account for the fact that time passes slightly faster in their orbits than it does on Earth's surface due to the weaker gravity they experience. Without correcting for this relativistic effect, GPS coordinates would drift by several miles each day, making navigation impossible. This time, dilation becomes more extreme near massive objects like black holes, where time can slow to a crawl relative to distant observers. Near the event horizon of a black hole, time becomes so distorted that what seems like moments to someone falling in could appear as hours or years to someone watching from a safe distance. The Oort cloud, a spherical shell of icy objects surrounding our solar system, extends nearly halfway to the nearest star. This vast reservoir of comets begins about 2,000 times farther from the Sun than Earth and stretches outward for over a light year in all directions. The cloud contains billions or perhaps trillions of icy bodies left over from the formation of the solar system, occasionally disturbed by passing stars or galactic tides, to begin long journeys toward the inner solar system as comets. These frozen wanderers carry with them pristine samples of the primordial material that formed our solar system over 4.5 billion years ago. The Oort cloud represents the true boundary of the sun's gravitational domain, a vast sphere of influence that extends far beyond the orbits of the planets. Radio waves from Earth have been traveling through space for over a century, carrying our first television and radio broadcasts to distant stars. These electromagnetic signals expand outward in an ever-growing bubble, now encompassing hundreds of star systems within a radius of about 100 light-years. Any alien civilizations within this cosmic sphere could potentially detect these transmissions and learn about human culture, though the signals become increasingly faint as they spread across the vastness of space. Our earliest radio transmissions are now passing stars that may harbor planets where other forms of life might be listening for signs of intelligence in the cosmic static. Titan, Saturn's largest moon, has lakes and rivers of liquid methane flowing across its surface. This distant world experiences weather patterns similar to Earth's water cycle, but with methane taking the place of water in a much colder environment. Thick orange clouds of nitrogen and methane shroud the moon's surface, occasionally producing methane rain that fills vast lakes near the polar regions. The largest of these hydrocarbon seas, Kraken Mare, is larger than the Caspian Sea on Earth and reaches depths of over 500 feet. Titan's dense atmosphere and organic chemistry make it one of the most Earth-like worlds in the solar system, despite surface temperatures cold enough to freeze methane into solid rock. The empty space inside atoms is so vast that if an atom were scaled up to the size of a football stadium, its nucleus would be smaller than a marble at the center of the field. This means that the matter making up your body and everything around you is mostly empty space held together by electromagnetic forces. The electrons orbiting the nucleus exist in probability clouds rather than fixed paths, creating the illusions of solid matter through their rapid motion and electromagnetic interactions. Despite this apparent emptiness, the forces binding atoms together are incredibly strong, giving matter its structural integrity and allowing the complex chemistry that makes life possible. White dwarf stars are the dense remnants of sun-like stars, containing about as much mass as our sun compressed into a sphere roughly the size of Earth. These stellar corpses are so dense that a teaspoon of white dwarf material would weigh as much as a car on Earth's surface. As white dwarfs slowly cool over billions of years, they will eventually become cold, dark objects called black dwarfs, though the universe is not yet old enough for any black dwarfs to exist. Some white dwarfs exist in binary systems where they gradually accumulate material from a companion star, occasionally erupting in nova explosions that can briefly make them visible across vast distances of space. The edge of our solar system is defined by the heliopause, where the solar wind meets the interstellar medium in a cosmic boundary that shifts and flows like an invisible ocean. Beyond this frontier lies the true emptiness between stars, where temperatures drop to just a few degrees above absolute zero, and matter becomes so sparse that a single hydrogen atom might drift alone through a volume the size of a house. The solar wind, a stream of charged particles flowing from our sun, creates a protective bubble around our entire solar system called the heliosphere. This magnetic cocoon shields us from some of the galaxy's high-energy cosmic rays, though it cannot stop them all. When Voyager 1 crossed this boundary, it detected subtle changes in the cosmic background radiation, marking humanity's first direct measurement of the space between stars. Comets are time capsules from the birth of our solar system, preserving primordial ice and dust in their frozen cores for over 4 billion years. These wandering snowballs spend most of their lives in the cold darkness of the outer solar system, where they remain unchanged since the earliest days of planetary formation. Only when their elliptical orbits bring them close to the sun do they come alive, sublimating ice directly into gas and creating the magnificent tails that can stretch millions of miles across space. The dust they shed continues to orbit the sun long after the comet has passed, creating meteor showers when Earth passes through these debris streams. Some comets may have delivered the water that fills our oceans, carrying the ingredients for life from the frozen depths of space to warm, welcoming worlds. The aurora borealis and aurora australis paint Earth's polar skies with curtains of green, blue, and red light created by solar particles colliding with our atmosphere. These celestial light shows occur when charged particles from the sun follow Earth's magnetic field lines down toward the poles, where they strike oxygen and nitrogen atoms in the upper atmosphere. Oxygen creates the familiar green glow at lower altitudes and rare red displays higher up, while nitrogen produces blue and purple hues that dance across the night sky. The intensity of these auroras depends on solar activity, becoming more spectacular during periods when the sun releases powerful coronal mass ejections toward Earth. Ancient cultures interpreted these lights as spirits dancing in the sky, unaware they were witnessing the visible evidence of our planet's magnetic shield protecting us from the solar wind. Pulsars are neutron stars that spin with such precision they rival atomic clocks, sweeping beams of radiation across space like cosmic lighthouses. These collapsed stellar cores rotate hundreds of times per second while maintaining timing accuracy that allows astronomers to detect gravitational waves and test Einstein's theories of relativity. The fastest known pulsar spins over 700 times per second, approaching the theoretical limit before centrifugal forces would tear even neutron star material apart. As these dense objects rotate, they drag space-time itself around with them in an effect called frame dragging, warping the very fabric of reality in their vicinity. Some pulsars exist in binary systems, where they gradually consume their companion stars, spinning faster and faster as they gain mass and angular momentum. Red dwarf stars burn so slowly and efficiently that they can continue fusing hydrogen for trillions of years, far longer than the current age of the universe. These small, cool stars make up about 75% of all stars in the galaxy, yet they are so dim that none are visible to the naked eye despite being our most common stellar neighbors. Their incredibly long lifespans mean that every red dwarf star that has ever formed is still shining today and will continue burning long after larger stars like our sun have exhausted their fuel and died. Planets orbiting in the habitable zones of red dwarf stars must be tidally locked, with one side permanently facing the star while the other remains in eternal darkness. This creates extreme temperature differences between day and night sides, though thick atmospheres might help distribute heat around these alien worlds. The cosmic calendar compresses the entire history of the universe into a single year, with the Big Bang occurring at midnight on January 1st and the present moment at the stroke of midnight on December 31st. On this scale, our solar system formed in early September, and the first life on Earth appeared in late September. Dinosaurs ruled the Earth only during the last week of December, while all of recorded human history occupies just the final few seconds before midnight on New Year's Eve. This perspective reveals how brief our existence has been compared to the vast cosmic story, yet it also shows how much has happened in the universe's 14 billion year history. Every second on this cosmic calendar represents over 400 years of actual time, emphasizing the incomprehensible scales involved in astronomy. Dark matter makes up approximately 27% of the universe, yet we cannot see it directly and know almost nothing about what it actually is. This invisible substance reveals itself only through its gravitational effects on visible matter, bending light around galaxy clusters and influencing the rotation of spiral galaxies. Without dark matter's gravitational scaffolding, galaxies would fly apart, and the large-scale structure of the universe could never have formed. Scientists have proposed numerous exotic particles to explain dark matter, from axions to weakly interacting massive particles, but none have been definitively detected, despite decades of sophisticated experiments. The mystery of dark matter represents one of the greatest puzzles in modern physics, a reminder that we still understand very little about the true nature of the cosmos we inhabit. Hypervelocity stars race through the Milky Way at speeds exceeding the galaxy's escape velocity, destined to wander forever in the emptiness between galaxies. The stellar exiles were likely ejected by close encounters with the supermassive black hole at our galaxy's center, accelerated to incredible speeds through gravitational slingshot effects. As they flee the galaxy, they carry with them any planets or moons that might orbit them, creating lonely solar systems drifting through the cosmic void. Some of these runaway stars may have originated in other galaxies entirely, captured temporarily by the Milky Way's gravity before being flung back into intergalactic space. Their trajectories tell stories of violent encounters in the galactic core, where gravity becomes so intense that even stars cannot maintain their peaceful orbits. The Kuiper Belt beyond Neptune contains thousands of icy worlds left over from the formation of our solar system, including dwarf planets like Pluto, Eris, and Makemake. This region represents the solar system's deep freeze, where temperatures are so cold that methane and nitrogen exist as solid ice on planetary surfaces. Many Kuiper Belt objects have unusual orbits that take them far from the Sun before returning to the outer solar system in elliptical paths that can last centuries. These distant worlds preserve the original composition of the solar nebula, offering clues about the chemical conditions that existed when the planets first began to form. Some of these objects are binary systems, where two similar-sized bodies orbit each other in a slow gravitational dance at the edge of known space. Solar flares and coronal mass ejections from our Sun can disrupt satellite communications and create spectacular auroras visible far from the polar regions. During periods of high solar activity, these eruptions release more energy than billions of nuclear weapons, hurling charged particles across the solar system at millions of miles per hour. When these solar storms interact with Earth's magnetic field, they can induce electrical currents in power grids and cause widespread blackouts, while also creating auroras visible as far south as Mexico or the Mediterranean. The largest recorded solar storm, the Carrington event of 1859, caused telegraph systems worldwide to fail and created auroras so bright that people could read newspapers by their light. As our technology becomes increasingly dependent on satellites and electronic systems, understanding and predicting space weather becomes crucial for protecting our modern civilization. Exoplanets orbiting other stars number in the thousands, with new worlds discovered almost daily by space-based telescopes and ground-based observatories. These alien worlds come in varieties unknown in our solar system, from super-Earths with masses several times our planets, to heat Jupiters that orbit their stars closer than Mercury orbits our Sun. Some exoplanets are tidally locked to their stars, while others follow highly elliptical orbits that create extreme seasonal variations lasting decades or centuries. Scientists have discovered planets made of diamond, worlds where it rains molten glass sideways, and systems with multiple stars, where planets experience complex day-night cycles as different suns rise and set. The diversity of exoplanets suggests that our solar system may be unusual rather than typical, making Earth's habitability even more precious and remarkable. Gravitational lensing occurs when massive objects bend space-time so severely that they act like cosmic magnifying glasses, focusing and distorting the light from more distant objects. Galaxy clusters can create multiple images of the same background galaxy, sometimes forming perfect Einstein rings, where light is bent into circular arcs around the lensing mass. This effect allows astronomers to study the most distant galaxies in the universe by using closer galaxy clusters as natural telescopes that amplify faint, faraway light. Strong gravitational lensing can also reveal the presence of dark matter by showing how it distorts space, even though it cannot be seen directly. Some of the most distant and earliest galaxies ever observed have been discovered through this cosmic magnification, appearing as they were when the universe was less than 1 billion years old. Binary star systems are far more common than single stars like our Sun, with most stars existing in gravitational partnerships that can last for billions of years. These stellar couples orbit their common center of mass in a cosmic dance, sometimes so close that they share atmospheric material or even merge into single, more massive stars. In some binary systems, one star evolves faster than its companion, becoming a white dwarf that gradually strips material from its partner in a process that can lead to spectacular nova explosions. Other binaries are so widely separated that their components appear as individual stars to casual observers, only revealing their partnership through careful measurement of their orbital motion over years or decades. The complex gravitational interactions in binary systems can dramatically affect any planets that might orbit them, creating unstable regions where worlds cannot maintain stable orbits. The concept of habitable zones around stars defines regions where liquid water could exist on planetary surfaces, but these zones are not fixed and change as stars evolve over time. For stars like our Sun, the habitable zone currently extends from about Venus's orbit to just beyond Mars, though atmospheric effects determine whether planets actually maintain liquid water. Red dwarf stars have habitable zones much closer to the star, while massive blue giants have zones so far away that any planets there would receive less energy than Jupiter does from our Sun. As stars age and change brightness, their habitable zones migrate inward or outward, potentially turning previously frozen worlds into temperate oases, or boiling away the oceans from planets that were once Earth-like. This cosmic climate change occurs over millions or billions of years, giving life potential opportunities to adapt or migrate to more favorable locations. The interstellar medium between stars contains vast clouds of gas and dust that serve as stellar nurseries where new stars are born. These nebulae can span hundreds of light years and contain enough material to form thousands of sun-like stars, yet they are so tenuous that the best laboratory vacuums on Earth are denser than most of these cosmic clouds. Within the densest regions, gravity slowly overcomes gas pressure and begins to collapse the cloud, eventually creating the hot, dense cores where nuclear fusion ignites and new stars begin to shine. The process of star formation enriches the surrounding medium with heavier elements forged in stellar cores, gradually changing the chemical composition of the galaxy over billions of years. Some nebulae glow with the light of newly formed star sayest, while others remain dark until disturbed by shock waves from nearby supernova or the gravitational influence of passing stars. Quasars represent some of the most energetic objects in the universe, powered by supermassive black holes consuming enormous amounts of material in the cores of distant galaxies. These cosmic beacons can outshine entire galaxies containing hundreds of billions of stars, making them visible across billions of light years of space, despite being relatively small regions around central black holes. The material falling into these black holes forms accretion disks that heat up to millions of degrees, creating intense radiation that jets outward at nearly the speed of light. Most quasars existed when the universe was young and galaxies were still forming, suggesting that supermassive black holes played crucial roles in shaping the early cosmos. The light we see from the most distant quasars left them when the universe was less than 1 billion years old, providing windows into cosmic history from an era when the first galaxies were just beginning to shine. Eyes were just beginning to shine. Rogue planets drift alone through interstellar space, ejected from their birth systems to wander the galaxy without the warmth of a star. These cosmic orphans were likely cast out during the chaotic early stages of planetary formation, when gravitational interactions with massive planets or nearby stars sent them tumbling into the cold emptiness between star systems. Some estimates suggest there may be billions of these nomad worlds drifting silently through our galaxy, invisible and undetectable except when they occasionally pass in front of distant stars. Despite their isolation, some rogue planets might retain enough internal heat from radioactive decay or leftover formation energy to maintain subsurface oceans beneath frozen crusts. These wandering worlds represent a completely different, niche category of potentially habitable environments where life might exist in the perpetual darkness of deep space, sustained entirely by geological processes rather than starlight. light. The Chandrasekhar limit defines the maximum mass a white dwarf star can support before collapsing catastrophically into a neutron star or black hole. When a white dwarf approaches this critical threshold of about 1.4 solar masses, electron degeneracy pressure can no longer support the star against its own gravity. The resulting collapse happens in a fraction of a second, compressing the star's core to nuclear densities while releasing more energy than our sun will produce in its entire 10 billion year lifetime. This limit represents a fundamental boundary in stellar evolution, determining the fate of stars based solely on their mass. Stars that exceed this limit cannot end their lives peacefully as white dwarfs, but must undergo violent transformations that can be seen across cosmic distances as supernova or gamma ray bursts. Cosmic rays are high-energy particles that constantly bombard Earth from deep space, some carrying energies millions of times greater than anything produced in human particle accelerators. These subatomic travelers originate from supernova explosions, black hole jets, and other violent cosmic events, racing through the galaxy at nearly the speed of light for millions of years before randomly striking our atmosphere. When they collide with air molecules high above Earth, they create cascades of secondary particles that rain down toward the surface, occasionally flipping bits in computer memory or causing unexplained electronics failures. The most energetic cosmic rays carry so much power that a single particle contains as much kinetic energy as a well-thrown baseball, concentrated in a space smaller than an atomic nucleus. Scientists still debate the sources of these ultra-high energy messengers, though they likely originate from the most extreme environments in the universe. Brown dwarfs occupy the twilight realm between the largest planets and the smallest stars, massive enough to fuse deuterium, but too small to sustain hydrogen fusion like true stars. These failed stars glow dimly with the heat of their formation, slowly cooling and fading over billions of years until they become cold, dark objects indistinguishable from giant planets. Some brown dwarfs exist in binary systems with normal stars, while others drift alone through space as solitary embers that will eventually become invisible. Their atmospheres can contain clouds of molten iron and silicate particles, creating weather patterns unlike anything seen on planets in our solar system. Recent discoveries have revealed brown dwarfs with powerful aurora displays and strong magnetic fields, suggesting these objects are more dynamic and complex than previously imagined. The local group of galaxies contains over 80 members bound together by gravity in a cosmic neighborhood spanning roughly 10 million light-years across. Our Milky Way and the Andromeda Galaxy dominate this collection, with their combined gravity influencing the motions of dozens of smaller dwarf galaxies that orbit them like cosmic satellites. The entire local group moves through space together, drawn toward the massive Virgo cluster of galaxies that lies 54 million light-years away in the direction of the constellation Virgo. This larger motion adds another layer to our cosmic address as we participate in flows and streams of matter on scales that dwarf individual galaxies. The local group represents our immediate cosmic family, a gravitationally bound island of matter in the expanding ocean of space. Magnetospheres create invisible shields around planets with strong magnetic fields, deflecting harmful radiation and charged particles from space. Earth's magnetosphere extends thousands of miles into space, channeling solar wind particles toward the poles where they create the aurora displays that light up polar skies. Without this magnetic protection, solar radiation would gradually strip away our atmosphere, as appears to have happened to Mars billions of years ago, when its magnetic field weakened and disappeared. Some planets like Jupiter have magnetospheres so powerful they trap radiation in permanent belts that would be lethal to any spacecraft passing through them. The interaction between planetary magnetic fields and the solar wind creates complex boundaries and shock waves in space, invisible structures that shape the space environment around every magnetized world. Variable stars change brightness in regular cycles, pulsating like cosmic heartbeats as they expand and contract due to internal pressure waves. Cepheid variables are particularly important to astronomers because their pulsation periods directly relate to their intrinsic brightness, making them cosmic distance markers that helped establish the scale of the universe. RR Lyrae stars serve a similar function for measuring distances to nearby star clusters and dwarf galaxies, their regular flickering providing stepping stones for mapping the local cosmos. Some variable stars exist in eclipsing binary systems, where one star regularly passes in front of its companion, creating predictable dips in brightness that reveal the sizes, masses, and orbital characteristics of both stars. These stellar lighthouses have been crucial for understanding stellar evolution and the three-dimensional structure of our galaxy. Galactic cannibalism occurs when large galaxies consume smaller ones, gradually stripping away their stars and incorporating them into ever-growing stellar systems. The Milky Way shows evidence of this process in streams of stars that wrap around our galaxy like ghostly ribbons. The remnants of dwarf galaxies torn apart by our galaxy's tidal forces over billions of years. Computer simulations reveal that major galaxies like ours have consumed dozens of smaller systems throughout their histories, growing larger and more massive through these cosmic mergers. The process is surprisingly gentle for individual stars, which rarely collide during galactic mergers due to the vast distances between them. Instead, stars find themselves in new orbits around different galactic centers, while their original galaxy structures dissolve into the gravitational embrace of their larger neighbors. As we reach the end of our gentle journey through the cosmos, let your mind drift back through the 100 whispers we have shared tonight. From the stellar nurseries, where new suns are born, to the ancient light that carries messages from the universe's youth, each fact has been a small invitation to marvel at the infinite complexity surrounding us. The atoms in your body were forged in dying stars. The ground beneath you rides on drifting continents of stone, and above you, galaxies dance their slow waltz through time and space. These are not merely facts to remember, but reminders of your place in the grand tapestry of existence. You are made of star stuff, connected to every distant quasar and wandering comet through the fundamental forces that shape reality itself. The universe has been patient, waiting billions of years to create minds capable of understanding its beauty, and tonight you have listened to its ancient stories whispered across the void. Let these cosmic truths settle into your thoughts as sleep approaches. Tomorrow the stars will still be there, spinning their silent stories in the darkness, waiting for you to look up once more in wonder. The cosmos has shared its secrets with you tonight, and in return, it asks only that you remember how extraordinary it is to exist in this moment, in this place, as part of this vast and beautiful universe. Sleep well, knowing you are home among the stars.